Hey everyone. All right, let's give it a minute for people to join us. And while we're doing that, I will pull up a couple things. All right, I see people are joining us. Looks good. All right, I think we've hit 40 people. So let's get started. A couple of quick things, just quick announcements. Let's see, let me share my Safari window. Okay, hopefully everybody can see that. Just give me a quick thumbs up if you can see Google. Yeah, good. Okay, cool. All right. Just a reminder how to find the course web page. And I just wanted to point something out real quick. So if you just Google me, and maybe if you add Pitzer to be sure, you should see a couple of different web pages there. You want the second one, which is the web page I created for myself, hosted at Pitzer. And down there at the bottom in the middle, you'll see CS5. And that is the web page that I created for at least this portion of the class, since we've diverged from the Harvey Mudd class. And I'm pointing this out for a couple reasons. I think I already said all this, but I wanted to make sure everybody knows where everything is. That's where the homework is that you've been doing and the labs that you've been doing. Also, the video, if you click on welcome back, then you'll go to a YouTube link, which is exactly just me babbling in class last Tuesday. So you'll see that. All right, that's better. I'm back. Okay. Yeah. And then if you click on the slides for today, if you look at April 2nd, under the slides column, you'll see the slides that I'm about to go through. So you can keep these up in a separate window if you want. You'll see me go through the slides and I'll be circling things with my pen and whatnot. Or you could come back to this. You know, in class, I always gave you a printout of the slides. I can't do that now, obviously, but you have a link to the PDF of the slides. So you can go back and review those yourselves. One other quick announcement on Gradescope. I had set things so that the deadline for the homeworks was either Monday night or Tuesday or Wednesday night, Monday night or Wednesday night at midnight. I had several students who are out of the country, like in China and India, email me and say, hey, that they wake up when it's, I don't know, 7 or 8 p.m. here. So that only gives them a couple hours to get the homework in. So I'm pushing back the deadlines for all future homework assignments to 8 a.m. the next morning. So instead of things being due Monday and Wednesday night at midnight, they'll be due at 8 a.m. Tuesday and Thursday. For most of you, it's not going to make much of a difference. You're going to want to get that homework done before you go to bed, because I suspect most of you are sleeping past 8 a.m. But this way, the students who are in other countries should have roughly the same opportunities as you guys. They'll wake up and have the same number of hours when they wake up to work on those homework assignments as you did before you went to bed. It's the only way I could think of to try to make things as equitable as possible. One other thing I mentioned last time, that this class may go to pass-fail if all the other Pitzer classes go to pass-fail. And I said, if you want a letter grade, you should email me I just want to remind you some things. I said, don't email me until I know whether or not the class is going to pass fail. I think the faculty are supposed to vote on that this afternoon. So I should know after today and have an update for you by Monday at the latest, I would think. If that does happen, if we go to pass fail for the whole class, I don't know how the letter grade appeal process will work. I originally said you should email me, and there's different proposals being floating around. Some of the proposals say that you're going to have to take it up with our academic standards committee if you want a letter grade, because there are some equity issues there. I think the reasoning is that those of you who are in some of you are struggling with situations where you got one computer in the house and there's 5 people struggling who are fighting to be online, or you're sharing a room with a sibling. And, I think we all know at this point, it's much harder for some of you than others. And getting a letter grade for a course could be viewed as an advantage over getting a pass for the course. And we don't want to create unfair advantages for those students who are in situations that are easier than other students. So there are some equity issues just giving the option of having a letter grade versus a pass. So again, I mean, some people have very good reasons why they need a letter grade, and all those things are being considered. And we've asked the Student Senate for their viewpoint on this and gotten some feedback from them. And so all this will be considered later, and it's very complicated. And I'll just keep you posted what the answers are. Okay. All right, before we get started on today's material, are there any quick questions? I don't have a chat window up. Let me pull up a chat window. You can just turn on your mic and let me know if you have any questions, or you can use the chat window, which I have up now. Looks pretty quiet out there. All right, I think we're good. All right, you'll notice now we're 8.2, 8.1, 8.2, 8.3. Those are now passed, they're done. And so, I've got to update this page. It says due at midnight now for those, and I got to change it to due at 8 a.m. and advance all the dates by 1. I'll take care of that. So 8.4 is your next homework assignment, and 8.4 will be due not 4/6 at midnight, but 4/7 at 8 a.m. I'll correct that. So today's lecture is pretty much just going to be about that one homework assignment. But to do that one homework assignment, we got to introduce several new Python commands. So this homework assignment you should just view as just a way to introduce you to a couple, about 5 or 6 different new Python commands. So we're going to walk through the homework assignment and at the same time teach you some new commands. So let me pull it up now. Let's see, I've got to change my screen share, so give me a minute here. There. And you're all seeing an iPad screen now, right? Oh, except it just disappeared, didn't it?
We can still see it.
Still see it. Okay, good. Okay. All right. So this is what this homework assignment is going to look like. We're going to do TT securities. And I forget what TT stands for. Undoubtedly some cute inside CS5 joke. The idea is you are going to input into, when your program runs, you're going to be given the opportunity to input a list of numbers. And then you're going to have, the program itself will give you a list of choices. And then when you select a choice, something is supposed to happen. Okay, the list of numbers that you're going to see are supposed to indicate stock prices. So if you input the list 40, 80, 10, 30, 27, etc., then that's supposed to represent the price of some stock on day 0, day 1, day 2, day 3, etc. So the day corresponds to that number I, the index. That's your day. And X is your stock price. Okay. And really your job is going to be to implement this text menu over here. Okay, so you've got to display that text menu to the user. That's easy. That's just a bunch of print statements. And then you've got to sit there, have the program sit there and wait till the user makes a choice. Then you have to do something depending on what that choice is. Okay, and then maybe go back and print the menu again to give them another, let them have another choice. Right, so there's going to be a lot of looping, and a lot of these individual operations that you see will involve writing other functions and creating other loops. Essentially, each of these menu items corresponds to another function that you will write, and you'll call that function when the user selects that menu item. All right, so the first step, the first challenge is how do you accept input from a user? And that's where the Python input statement is going to come in. So input is a statement that'll allow the user, it'll prompt the user. It does two things. First of all, it'll print out this text string right here, and then it'll allow the user to type some response to this question. It's like, so the question here is how many meters? So this will type out to the screen how many meters, and then it'll give you, then the next thing the computer will do would be, if you look at this code, it looks like the next thing that happens is that whatever the user picks is going to now be named meters, okay? And then it's going to, what it looks like this code is supposed to do is compute the number of centimeters from the number of meters by multiplying by 100, and then print that back out to the screen. What it'll print is that's however many centimeters, and then cm, okay? That seems like it's pretty straightforward. It seems like it's pretty easy. The problem is it won't work. This will not give you what you want. In fact, what this will give you, if the user enters 45, or let's use our generic 42 for Python. If the user enters 42, what'll happen is meters will be set to the string 42. So whatever an input statement gives you, the result will always be interpreted as a string, even if the user inputs a number. So that makes it a little bit tricky. So what I'll print here is that's 42, 42, 42, 42, 42, cm, right? Because the string 42 repeated 100 times, that's what happens when you multiply a string by 100. Right. Clearly, that's not what we want. We want 4,200, not 42, 42, 42, 42, 42, 100 times. Okay. So when you use an input statement, if you want a string, that's fine. But if you don't want a string, you've got to convert it from a string to a number. So we have a couple of different commands to convert one data type to another. And we've seen these before. They've come up, and I don't remember if it's come up in class before, but certainly as I've been walking around the class and labs and whatnot and helping you, I've suggested you use functions like this. So there's the str command to convert something to a string. The int command will convert anything to an integer. And what we see right here is the float command will convert anything to a floating point number. So a floating point number, again, you should just think of that as a decimal, okay? So this would be how you would fix it. So the user enters m string, so it enters meters as a string, and then meters is what you get when you convert that string to a decimal, okay, which is what's happening right here, okay? So, and then once we convert that string to a decimal, then we can multiply that decimal by 100, and then finally we get the right answer down there for cm. What can go wrong with this? Why is it crashable? Down here at the bottom, it says it's crashable. How come? Somebody want to just enter it in the chat window? Just think of what might happen that will make this program crash if someone tries to run it. I'm really going to use the chat window here. I got it up. I'm waiting for somebody to say it. Oh, there we go. Max said it. If the user enters a word, it can't convert to a float. Yeah. Let's say at the very beginning, we run this program. So when we run it, the first thing the user will see is the question, how many meters, how many m question mark. And then if the user types in 0 for 0, the computer can't convert zero to a float. It doesn't know that the word zero is the number zero. So what's going to happen when you type float zero is it'll give you an error. So this program will just stop and crash and say, hey, error, I can't do that. All right. So that's called an exception. Whenever a program crashes, it always crashes for a reason, and the reason is called an exception. And so the next thing we're going to learn is how to handle exceptions. This is a really, really important concept for any computer programmer, is learning how building into your program contingencies for when errors happen. So instead of the program just crashing and just stopping, the program should do something if it generates an error, and the programmer might anticipate what kind of error could happen. So if you anticipate in advance that, hey, maybe the user entered a string that can't be converted to a float, you can build in some exception handling here to compensate for that error that might be generated. So this is the new commands. It's the try command, and that's always paired with the accept command. So you literally tell Python, hey, let's try to do this, but don't crash if it doesn't work. If it doesn't work, we will do something if there's an exception. And that's what the accept part of it does. So it's a lot like an if-then statement, right? If we have an if command and it's false, then we go to the else, right? So it's a lot like if else, try except. We try the command under the try command, and if that generates an error, then we go to the accept portion. So let's see what happens here with this particular program. Is we start there at the top, we ask the user how many meters. If the user puts in a number like 42 or 47 or whatever, that's fine. We run this meters command, meters becomes the number 47 or whatever, and then we jump down out of the loop down to there and we multiply that number, and it's fine, okay? But if the user entered something from the beginning that it can't convert to a float, then we go down to the exception. Then we tell the user, this is another important thing, is if you can't use the user's input, you should really tell the user, hey, I can't use your input, so I'm going to use some default input, right? So we print out to the screen, some error message like error, I can't do that, right? And then you tell the user what it is you're going to do, and the thing we're going to do is set meters equal to the number 42. Now when we leave this whole try except block, when this whole block leaves, no matter what happens, no matter what the user entered, meters is now a floating point number. Meters is now some real number. And now we can multiply that float by 100 and then move on to the print statement. Okay. This is a nice way to handle, again, as the programmer, you've got to think when you program, what kinds of errors can this generate when I allow the user to enter different things? And what am I going to do in those cases? Right? That's going to depend on what program you're generating. Okay, and that's called, that general process, that general thought process is just called exception handling. And there's more advanced ways to do exception handling. You can actually ask Python what kind of exception was generated and do different things depending on what kind of exception was generating. We're not going to get that sophisticated in this course, but you should be aware that there's much more sophisticated kinds of exception handling. But for now, we're just going to think about simple cases where just some error was generated, doesn't matter what, and we'll just do something else in that case where some error was generated. There's another option here, which is the eval command. The eval command is kind of interesting. The eval command, what it does is it takes some user input, interprets that as a string, and then the eval command runs that string as if it were its own Python program. So it's kind of interesting. So let me flip over. Let me change the screen I'm sharing. Let's see. I'm going to change the screen I'm sharing to my VSC screen. Okay, so hopefully you can all see that. Right there's my code window, and let's try some of these commands out real quick. So I'm going to try input. Let's see. Code equals input, enter some code. All right, so now when I hit enter, this will execute. And what I should see on the screen is the question, enter some code. Oh, there it is, right? Enter some code, I just did it. And now whatever I type will be interpreted as a string, and it'll be the string code. All right, so here's what I'll type print hello. Okay, all right, so there it is. So now if I ask for what the value of code is, it's the string print hello. Okay, now I can tell Python to evaluate that string. Eval, let's evaluate that code, and it executed the command print hello and printed hello. Right? So the eval command literally takes any string and evaluates it as if it were a Python command. Okay? So let's see what happens if I have a Python command that's just a number. Let's see what happens if I eval that. I eval the string 42, it's saying, hey, 42 is what somebody else typed into the code window, and if I evaluate the single line Python command 42, it prints out 42. Okay, so that's another way to handle, instead of try except, we could just use eval. So let's go back to my iPad screen now, and sorry, give me a minute. It always takes a minute when I switch screens. So that's another way to do things. You can still get an error. Not every string can be evaluated as a Python command, right? A user could just enter some gibberish, and then when it tries to evaluate that gibberish as a Python command, it won't know what to do, and you can still get an error. So it's still good to put the eval command here in a try except thing. Right, so instead of converting it to a float, we're just going to evaluate the string and hope that the user entered a number, and then we evaluate that string number, it'll just be a number. Okay. Now, here's the big question. The eval command is super, super, super dangerous. This is not the recommended way to do this. It's useful in certain circumstances, but and you should know it. You should be aware of the eval command, but it's super dangerous. Why? Somebody type in the chat window, why is the eval command so dangerous? What can go really wrong if you allow the user to enter some code and then evaluate the user's code?
You can put in the wrong code.
They can put in the wrong code, and if they were malicious, they can put in code that creates a virus on your computer. This is one way people write viruses, is they look for other people's code that lets them input some text and then evaluates that text as a program and then runs that program on their computer to do something malicious to their computer, right? So the eval command is really dangerous. You're giving the user control over your computer because you're going to evaluate their code on your computer, right? If you know the user, or maybe you're the user, you're writing a program for your own future use, then that's not necessarily such a bad thing. And sometimes the eval command is super, super useful and you do want to use it. You just got to be careful. If you use the eval command and hand this off to another user, then just be careful. Okay? So sometimes it's a nice thing to do, but just a word of caution there with the eval command. All right, let's go back to the homework problem. Again, the homework problem, your first challenge at the homework problem is to print out the menu to the user, and then you should let the user make a choice, okay? So there's a couple things going on here. This is how you're gonna do it. And let me move this out of the way. No, you should let the user make a choice. And there's a few things here. So def main, that means we're writing a function called menu, right? That's the menu function up there. All the menu function does is print the menu, that's it. Now, when you run this, that first block of code does nothing. You're not printing the menu here. You're writing a function that prints the menu if someone calls that function, right? So we're putting those print statements inside a function command. Nothing happens until we call the function menu. Okay, so that's one important thing to know, is that when this part of the code runs, nothing happens. It just defines a function that prints the menu. It doesn't actually print the menu until someone calls that function. All right, another important thing, there's lots of important lessons on this slide. Another important thing here is you'll see a main definition. This is really, really, really typical. And in functional programming, this is really common. Almost every Python program you will see any programmer write has a main function at the very bottom. And often all the main function is doing is it calls a sequence of other functions that were written. So usually the right way to structure your code, if you're writing a large Python program, is you write a whole bunch of helper functions, many, 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 many helper functions, maybe hundreds of helper functions. And then at the very, very bottom, there's a main function that kind of calls all those helper functions. That's all it does, right? This particular main function does more than that, but that's typical programming structure. That's why we call it functional programming, because all the work is being done with functions that are all called together in one main function, okay? Now, when you run this Python program, again, nothing happens. You've taught the user the menu function. You've taught the computer the menu function by running the bit at beginning. You've taught the computer the main function. And then what the user will do at the command line, all they'll do is type main, and then the program will run. And the first thing that happens when the program runs is we enter a while loop. And now here's a while loop that's kind of a funny loop, because it's going to keep running and running and running and running and running whenever what's here is true. But what's there, what I just circled, is always true, okay? So this while loop is just going to run forever until you choose one of the options that breaks you out of it, right? And that's going to be option 9. When the user picks option 9, then there'll be a break statement that'll break us out of this loop, right? So we'll just keep repeating this while loop over and over and over and over and over again, giving the user choices every time we repeat the while loop. Every time the user picks a choice, this program is going to do something, okay, until the user picks choice 9, in which case the program will be a break statement, and we'll break out of this loop, and then the program will end. All right, so that's the next thing, okay? The next thing that happens is this menu command. So now we're calling this menu function, which finally calls this whole block of code up top, right? So we enter this infinite loop, and immediately the first thing we do when we enter this infinite loop is we print out the menu of options for the user, okay? Then we use this new input function to ask the user for a choice, and the letters UC stands for user choice. So user choice are the next thing we do here. And then we're gonna, again, use our try except. Sorry, my iPad menu here for my pencil is covering up the bottom. What we see down there at the bottom is that try except. So UC for user choice, we're gonna try to use the choice that the user implemented. So again, input, let's say, so I'm babbling a little bit here. So we said UC equals input which option, right? Now let's say the user enters 3 for option 3. Or actually, that's not one of the choices here. Let's say the user enters 1 for option 1, okay? Well, now UC will be the text 1, right? UC will then be, UC equals the text 1. Right, so now we enter this try except here, where we want the UC to turn into an integer unless the user entered something that can't be turned into an integer. In which case now we go to the except, and under except we see that word continue. Continue. Okay, and that word continue is a new word for us as well. We're learning a lot of new commands here. Okay, continue. What that does, that can be used inside any for loop or any while loop. And sorry, I keep covering up the bottom of the screen. I'm still working on the technology here. The continue command inside any loop, either a for loop or a while loop, when you hit that continue, if we, so there's two important words with loops, okay? Break, easy, breaks you out of the loop, right? The loop stops running. Continue just takes you back to the top of the loop. This is going to look for where the while started and bring you all the way back there. If we get to that continue, we're going to go all the way back to the beginning of the while loop and keep going. Okay, so if the user doesn't enter, let's go back for a minute. If the user enters a choice that's somehow not an acceptable choice, then we'll just print the menu again and ask the user to make another choice. Right? So if the user enters some gibberish choice, it'll go to the accept part, and on the accept part you see that continue command, and that continue command will bump you back up to the top of the while loop, and the first thing that'll happen at the top of the while loop is it'll reprint the menu of options and then again asks the user to make a choice. Good? All right, let's go forward. All right, so now we're trying to put this all together to kind of build you up to that homework problem, right? So again, that homework problem, you have a list of stock prices and you have a menu of options, okay? So there's your list of stock prices right there at the top, okay? Now we jump into this infinite loop that runs over and over and over again until the user selects quit, okay? Then we print the menu out for the user. Then we ask the user for a choice. And there's some ... here because you want to now convert that choice to an integer, and that you want to put into a try except command like on the previous slide, etc. We just talked about all this. All right. Now we've got to evaluate and do things based on what choice the user made. So now it's just a whole bunch of if and elif commands. Right? If the user chose 9, do one thing. If the user chose 0, do one thing. If the user chose 1, do another thing. If the user chose 2, do another thing. Okay, so these are the things we're supposed to do. Let's go just back. Let's just look at these commands right up here. If the user chose 9, then the first thing we're supposed to do is break out of the loop. Okay, if the user chose 0, then we just continue, meaning don't do anything, reprint the list, let the user pick another choice. So let's just look at those. Let's go forward now. So if the user chose 9, that's here, then there's that break command. That's the quit. Break out of the loop, stop, program's over, done, go home. Okay? If the user chose 0, then we're supposed to just reprint the menu, continue on, let the user make another choice. And that's why that's exactly what that continue command does, is it goes back to the top of the while loop and runs the whole while loop again from the beginning. All right, now going back, what about 1 and 2? 1 and 2 are supposed to allow the user to enter a new list, that's 1, and 2 is supposed to be analyze that list. So 1 is going to be some sort of input eval statement to check for a new list, and 2 is going to be do some analysis, and to do some analysis you're probably going to write some other function which analyzes your list. All right, this is a simple version of the homework problem you're going to do. The homework problem you're going to do has lots of other things, other commands that you may want to write that you're going to be required to write. So you're going to have to compute the average price of all of the stocks in the list. You want to find the standard deviation. That's just going to be implementing this formula. You don't actually have to know what standard deviation is. If you've taken a statistics class, you should know what standard deviation is. That should look super familiar. If those words mean nothing to you, just type in this formula. That's all you have to do. If you're supposed to find the minimum, the day where the minimum stock price happened and what the price was on that day. That's function 4 there, is the minimum price and the day on which that minimum price happened. Function 5 is the opposite, it's the maximum price and the day on which that maximum price happened. And then 6 we'll talk about. 6 is let's say you had a crystal ball and somebody told you, hey, these are going to be the stock prices over the next week. On which day should you buy that stock and on which day should you sell that stock? That's exactly what option 6 is going to be. So it's kind of looking into the future, assuming these are going to be the stock prices for the next week. Now the computer's supposed to tell you what's the best days to buy and sell. That's your investment plan. Okay. All right. So let's talk about each of those. Let's talk about the minimum price first. So you're supposed to write, by the way, you're supposed to write all these commands yourself and not use built-in Python commands, right? So even if there's a built-in min function with Python, let's think about how we would write the min function itself. Because remember, min day does a lot more than just find the min of those prices. It also finds the day. So you can't just say min because then you won't know what day it is. So we've seen other ways to do this in the class by using lists of lists, but let's see how you would write it yourself. How would you find the smallest minimum price? It's a little bit weird me talking to you all out there. So I'm going to give you a minute. I'll give you, I don't know, give you 2 minutes. Think to yourself about how you would write a function to calculate the minimum price from a list, or just the minimum of any list. Just think for yourself. Use it. It's going to be, I'll give you a hint. You're going to be using a for loop to calculate the minimum price of some list. This is the little hint over here, right? Is you want to, inside your for loop, you want to keep track of the minimum so far for all the ones you're doing. So you have, right, going to think about this for loop that iterates through all the elements of the list and always keeps track of the minimum number you've seen so far until you get to the end when you're done. And then that minimum so far is the minimum of the whole list. So just think it's like 3 lines of code. Just think for yourself how you write those 3 lines of code. I'll walk you through the logic here for those of you who are having a little bit of trouble, right? So the logic is we're going to iterate through this list. So something like for x in L will give you all the elements of this list in order, right? And then every time you check the for loop, the first time through, you might want to say the first time through M is just the first number on the list, just L of 0, okay? And then the next time through the for loop, we're going to check, is the number we're looking at less than M or not? If it's not, we won't change the value of M. If it is, we will change the value of M to whatever the current value is, right? So when we see that 10, well, 10 is less than 40. Okay, now we'll look at the 30. We'll say, is 30 less than M? No, so keep M the same. Is 27 less than M? No, keep M the same. Is 52 less than M? Keep M the same. Right, and then finally, is 5 less than M? Yes, so we'll change M to 5. 5, and then when we're done, M equals 5. Hey, now we know the minimum. At the same time, though, it gets a little more complicated. At the same time, not only should we be keeping track of M, but we should keep track of the day that that's happening on. So you can keep track of the day. Whenever we change M, you should also change the day. Right, so here the day was 0. It stays day 0. Oh, now we've changed M to 10. So we changed the day to 2. Okay, and then M keeps going. Erase this. Can't erase this very well. The erase on here is terrible. Let's just keep going. Now M is 10, M is 10, M is 10. Here finally we've changed M again to 5, so we change the day to day 6. 6, and then we end, right? So by the time we're finished with all of this, the value of M is the minimum of everything in the list. And the value of D is the day on which that minimum happened. Okay? So again, I'm just trying to walk you through the logic here. I'll give you another minute or two to think about how you would write that as code. Again, it should just be 3-4 lines of code. That's it. How does this look? Anybody get some stuff? Okay, this is pretty good, except what we're missing here is the day. Right, this will at least give us the stock price. So take a look at this and tell me if it's similar. Hopefully it's similar to what you just came up with on your own. Right, so for X and L, that's gonna iterate through everything in the list. We'll start out assuming that the minimum price is on the first day. And then every time we go through the list, we're going to check, is the one we're currently looking at less than the value of M? And if it is, then we change the value of M. And then when we're finally done with this for loop, that's when we return M. Okay. That gives us the minimum price. Now you're also supposed to return the minimum day, right? So you got to think a little bit about how you would track that as well. And that's what I tried to explain over here is every time you change the minimum, every time you change the value of M, you should also change the value of D as well. So it's going to be in that if command, there's going to be a place to change D.
So would the function have to take two variables then, L and D?
Well, L contains kind of both information. L is the whole list. And the index of the things in L are the values of the list, or the values of the day, sorry. So L kind of has the day information built in because that number 40 at the top there, that's the index 0 element of L. So you should interpret that as day 0.
So how would you do the element, like print the?
So there's a couple ways to do this. Let's see. Let's go back. I wish I could pull up a blank screen. I don't know how to do that. Somehow there's a way to pull up a blank here. I'll try to squeeze it in. This isn't the best thing to do. So one thing you could do is instead of for X and L, you could do for I in range length of L.
Okay.
Okay. And now instead of using X, you would just use L of I, right? So then this if statement becomes if L of I less than M. Then we want to do stuff, right? So then one thing is we want to change the value of M. We can say M equals L of I, right? And we want to change the value of D, right? So then the day is going to be I. And change colors here. Today it's going to be I.
Okay.
Okay. Right. So
yeah,
changing the value of D to the current index. You know, before all that, we'll have to initialize. We'll have to say M equals. You could say M equals L of 0. And D equals 0. Right. Just to give you something to start with for M and D. Right. Now we're going to flip through, instead of flipping through the elements of M, the elements of L, we'll flip to the indices of the elements of L. And those indices correspond to the days. Right, so this is just an alternate way to do this where now you keep track of the day. Here's another new concept that we haven't seen before is, I think for every function you've written in this class, when you hit a return statement, you've returned one thing. Functions can return multiple things. So you just use a comma to separate it. So whenever you see a return statement, then you can return both the price and the day just by separating those with a comma. Okay, so functions can return all kinds of things. You can have 5 inputs to a function and 10 outputs to a function just by separating those outputs with a return. What you can't do is say return min price and then return min day, because the first time you hit a return statement, it kicks you out of the function. So it'll never hit the second return statement. So if you want to return 2 things, you have to do it this way. You have to just separate both those things with a comma in a single return statement. Okay. Hey, and this is exactly what we were talking about before. So I use D and they're using min day and min price. So this is just an alternate way to do exactly what I wrote before, very similar to what I wrote before, which is instead of iterating over the elements of the list, you iterate over the indices of those elements, which correspond to the days. Okay, you initialize, you set both things initially to the first value of the price and the first value of the day. Then you iterate over the indices. You check if an element corresponding to the ith index is less than the current minimum price. Right? Then if it is, you change the current minimum price and you change the day to whatever the current day is. Okay. And then when you're done, you're going to return both of those. All right, another thing you're going to need to keep track of is the minimum price difference between any 2 days. Okay, this is going to be more complicated. So again, I'm going to give you a little bit of time. I'll give you 2-3 minutes to think about this. To do this, you're going to have to use some nested loops because we've got 2 different things here. We've got to iterate. We've got to look at the second list and subtract, sorry, the second element of the list and subtract the first one from that. And then we'll look at the third element of the list and subtract the first and second one from that. And then we'll look at the fourth element of the list and subtract the first, second, and third one from that. So for each element of the list, we're going to subtract all the previous ones from it. And then we're going to keep track every time we do that of what the minimum we've seen so far when we do all of these differences. And that gives you the minimum price difference over any pair of days. Right? So again, you got to think about the logic here. We're going to iterate through every element of the list. Every time we're looking at one particular element, we'll iterate through all of the previous ones, compute all those differences, and continually check, is any difference we're seeing less than the minimum difference we've seen so far? Okay, it's not a very big program. Again, there's just, you can see by the blank spaces that have been left on this slide, there's not a whole lot of space here. Again, there's just a couple of lines for you to think about. Okay. This is actually structured slightly differently, but it's equivalent to what I just said. Another thing you can do, and it looks like that's how they're doing things with this slide, is you can iterate through every element of the list. And for each element, look at all the ones after it and do all those differences. Now we look at the next element, and now we look at all the ones after that. The next element, all the ones after that. The next element, all the ones after that. Compute all those differences and keep track of the minimum so far. That's actually how this, now that I'm looking at this slide a little more carefully, that's how this is structured. So I is just going to loop through all the elements of the list, right? That's what I is. And then J is going to loop through all of the things from I forward. And we're going to keep track of all the differences we see every time either loop runs and keep track of the minimum so far. So first of all, what's missing right here? Anybody want to just put it in the chat window? It's really short.
I plus 1.
Good, Nick. I plus 1. We don't want to use I, Because if we use I, the difference between the ith element and the ith element will be 0, which will always be less than whatever minimum we've seen so far, right? So we want the price between any two distinct elements in L. It's not useful if we include an element in itself, right? Now, what do we want to keep track of here? If what? What should be? Somebody put it in the text window. Just type it in. What's that missing block of code? I think it's actually just one line. And just be careful, we're looking at the absolute difference. Not the difference, but the absolute value of the difference. Somebody type it into the chat window. Nobody wants to venture guess in the chat window. Good. Somebody, Michelle, typed in, you have to check the absolute value of Lj minus Li, whether or not that's less than M difference, right? So if, let's see, min diff, M diff is less than the absolute value of L, either Lj minus Li or L minus Lj. I'm going to go with Michelle's suggestion. Okay. If it is, what do we do? Oops. Yes, thank you, Michelle. We actually want this one.
You said MDiff equal to the absolute value Lj minus Li.
Good. MDiff. Same thing. Right. Absolute value of Lj minus Li. Good. Let me understand why we have to use a nested loop here. Because we're going through each element of the list, and then for each element, we have to go through all the elements after it. All right. Then we advance the next value of I, and then all the values of j. And then the next value of I, and then all the values of j. Okay, really typical application of nested loops when we're looking at differences between pairs of elements of a list. Okay. All right, and that's exactly what they had. I plus 1 for j in range I plus 1 comma length L. Okay. You could do this differently. I think it's actually a little bit simpler to do this for j in range I. I think you can do that instead. To me, that's simpler. I'm not sure why they did it the more complicated way. So this has a slightly different logic to it, and it's what I originally said, where we increase the values of I, and for each value of I, we look at all the previous values and compute all those differences. I think we're going to get all the pairs of numbers doing it this way as well. To me, this one looks simpler. All right, last thing you've got to know for your homework problem. So you should know how to do the minimum in its day at this point, the maximum in its day at this point, right? Those are those nested loop plans. Those are those loops. The average price is just typing in some formula that you're just going to type in. You all know how to compute averages. Standard deviation, that formula is given to you on that slide, and it's probably in the, I assume it's in the homework assignment as well. So the last thing is this option 6. Quit is going to be the break command. So we already know how to do quit. Input a new list. This allows the user to just change the list, L equals whatever. Print the current list. That should be easy for you. It's just a simple print statement, right? So this is really the only thing left to talk about is the investment plan. So the investment plan, it's very, very similar to, it's very similar to, I don't know why this says hardware versus software. I'm going to guess that whoever wrote this slide um, is emphasizing to you that in the 21st century and beyond, this stock analysis, I'm sure you all know, people are looking at computers to analyze their stocks, and they've been doing so since the invention of computers. And this is true for really anything, which is that there's actually this fight going on between software and hardware. You want sophisticated software tools to analyze any set of data, and this is the whole field of data science now is really about the interplay between hardware and software here. We have these very sophisticated software algorithms, but those software algorithms only work now with very sophisticated hardware. So for example, people are using neural networks now to do a lot of stock analysis. Those neural networks often rely on running on massively parallel computers. The neural network algorithms won't work unless you have a lot of parallel processing. And that's a hardware issue, is how to develop a computer with lots of parallel processing. So if you're really interested in understanding how to do stock analysis, and if you're a finance geek and you want to really think about more sophisticated algorithms, you do have to kind of get under the hood and understand the hardware side of things and leverage that on the software side. What we're going to be looking at is a much, 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 much simpler kind of investment plan here, where, again, I had said this earlier today, you're assuming this is going to be the stock prices from now into the future. You have some model of your stock, and your model of your stock makes predictions for the value of that stock over the next 7 days. And then the question is, well, assuming your model is right, when should you buy and when should you sell? So you've got to think about this. If you were to buy on day 0 and sell on day 2, then you've made a profit of a negative profit, right? If you buy at 40 and sell at 10, you've lost $30, right? But if you buy at 10 and sell at 52, then you've made $42, right? So if you think about all the pairs of numbers here and look at the difference between those pairs and see which difference is biggest, that is exactly the correct strategy. So this is very, very similar to the min-diff algorithm that we saw a few minutes ago. But with the min-diff algorithm we saw, there's slight differences. Nice background, Mark. There's slight differences. With the min-diff algorithm, we were looking at the absolute value of the differences. Now we don't want absolute value, right? Because whether or not the difference is positive 30 or negative 30 is a huge difference. You want to know when you make $30, not when you lose $30. So to get the best profit, you definitely don't want to take the absolute value of the differences. And the other thing is, for your investment strategy, you want to know not just the difference, but what days to buy and sell. So you've got to return back to the user what the biggest day is for profit, what the biggest buy day and sell day is for profit, and what that profit is. Okay, so this is exactly a very similar sort of programming structure. We're going to have to use a nested loop to go through each day and each day after it. This is probably why on that previous slide, they arranged their nested loop to go through the values of I and all the values after it. Okay? That wasn't necessary when we were looking at the absolute values of differences, but now it's really going to be necessary. We're going to look at each possible buy day and then all the sell days after it. We don't care about the sell days before it because you can't sell before you buy, right? So now it makes a lot more sense if the outer loop is the buy day and the inner loop is the sell day, you want the sell day to always be after the buy day. So we always want to iterate through each element of the list and all the days after it to determine what selling point gives you the biggest profit. Nick, give your hand up. You have a question?
Yeah. So would we not want to take the absolute value then? if we're
Correct.
doing
Yeah. Yeah.
Okay.
Here you definitely don't want the absolute value, right? If you see a difference of 30 for some buy day and sell day versus a difference of -30 for some buy day and sell day, you definitely want the positive 30, not the negative 30.
Yeah.
Yeah.
Okay.
You want to maximize your profit. Yeah. I mean, you could also build in another function where you maximize your loss, and then you're looking for the biggest negative value, the most negative value. We're not going to bother with that, right? What you want to return after you write this code is all three different things: the profit, the buy day for that profit, and the sell day for that profit. Okay. So hopefully this should be pretty straightforward for you. Um, we've gone through pretty much everything here. Let's go back to the very beginning. Pretty much everything you have to do in your homework, I've kind of hopefully walked you through today. So you've got now 4 days to do it. It should just be done by Monday night. All you've got to do is I would just go through this slideshow that I just went through with you and just try to mimic what we have here and put it together. Again, you're going to have a menu function that prints out the menu, and then a main function wherever all the action's happening. Okay. You'll have a couple other helper functions before the main function. You'll have a helper function to compute the average price, a helper function to compute the standard deviation, to compute the min day, the max day, right? Each of those menu options should correspond to a helper function, right? So we've got, let's keep track of, we've got a helper function to print the menu, a helper function to print the current list, helper function for the average price, the standard deviation, the min in its day, the max in its day, and then the investment plan. So you're going to have 7 different helper functions and then a main function. Okay? All the main function is going to do is there's going to be this while true loop. That while true loop, the first thing that will happen is it'll print the menu, and then it'll ask the user for a choice. You'll have to do some exception handling there. You're going to convert the choice to an integer if you can, but if that generates an error, then maybe you go back to the beginning, right? So there's some exception handling there. Then there's going to be a bunch of if statements. If the user choice equals 9, then you hit that break command, you're done. If the user choice equals 0, 0, you're going to allow the user to input a new list, right? So there's a lot of if and elif commands, and each of those elif commands will just be calling one of your helper functions. And that's it. That's going to be the whole program. The min day, the min in its day, the max in its day, those helper functions will be a single loop where you'll go through the list and figure out the minimum and the maximum. And the investment plan is going to be a nested loop. That's how you write that function, where you go through each day for the buy day and look at all the sell days after that. And that's the investment function. Okay. Are there any questions before I let you all go? We're done a little bit early, but that's fine. This is all you got to do before Monday. Shouldn't take you too long. Good. All right. On Monday morning, I will have office hours in the morning, first thing in the morning. Okay. And then Monday afternoon, we've got an hour of lab, but I think most of you can probably handle this on your own. I'll be there sitting online from 1:15 to 2:15 Monday afternoon if you do have any questions, or you could come to my office hours Monday from 9 to 10:30. Otherwise, I'll see you all online on Tuesday. We good? Last other questions? Going once, going twice. All right. See you all Tuesday.
Thank you.
Thank you.